Video solution of the extra exercises on the solver. I will solve exercise 3.3 and exercise 3.6, which seem to create problems to some of you. Okay, let's start with 3.3. Is there any possibility to zoom here? Okay, you have a €2 voucher to spend on chocolate. There is a small bar, 100 grams, cost 70 cents. The large one, 250, is 32 cents. Well, it must be a very old exercise or a very cheap country. However, there is a special deals on the small bars, whereby if you buy 3, you get 1 free. You want to buy as much as chocolate as possible. Okay, ideally you want to spend every penny, as the shopkeeper doesn't give you any change. So it means that doesn't matter what I spend, I won't get back my money. But I want to maximize the amount of chocolate. Okay, let's set up the zoom. Oops, no. No. 3 fingers. Okay. So first of all, the variable. The variable says how many small bars. Variables, small and large. Let's start with 1 and with 2 small and 1 large. Okay. Objective function. My objective function is to maximize the amount of chocolate. So for the moment, it's simply the small one have 100 grams plus the large one have 250 grams. Constraints. Okay, well, the constraints I think are, for the moment, are simply that the small one and the large one are integer. I can't buy half. And then let's see the text. This sentence is not clear according to my opinion. You want to spend every penny. Well, it's not clear because if I don't spend every penny, it doesn't matter. So let's do first of all in this way. If I don't spend all of it, doesn't matter. There's another issue, however, this one, the special deal. Well, I think that it's not easy to implement. Let's see, I will implement it in this way. Sorry, there's another constraint I've forgotten. Maximum amount of money. That the total cost, which is 17 and 32. So equal small by 0, 17 plus large by 0.32. Must be smaller or equal than 2. 0 and 32. So 17 and 32. Okay. Okay. We could solve it up to here, but we are forgetting this extra constraint. There's a special deal. How to implement it? Well, since we don't actually pay it, I cannot modify manually the quantities, but I can modify the objective function. If I buy 3 small bars, okay, so I can modify the objective function. So the number of small bars only for the objective function, not for this thing here, maximum amount, because I'm not paying them, is this is difficult because it's b3 by 100 plus b2 by 100 plus b3 by 250 plus if b2 larger or equal to 3. In this case I have to add 1, so I have to add other 100 grams, otherwise nothing. Okay, and this will solve the issue of the case in which I buy 3 or more. However, what happens if I buy 6? Does it say something? No, doesn't. Well, I should also add the case if I buy 6. So if it is larger or equal than 6, I add other 100. I don't add 200 if it's larger or equal than 6 because I have already added 100 here. And I should do it also for 9, and I should do it also for 12, and so on. So I will do it also for 9. And let's do it also for 12. Okay, and I should go on doing also for 15, 18, until I'm sure that I can't buy that amount. This is a possible solution. Well, let's be honest, it's not the best one. There is another solution which divides B2 by 3, but let's stick with this one. So now where is the solver, where is the solver, where is the solver? Solver, here, solver. Set objective this one by changing the variable this one. Constraints. At small must be integer. Add large must be integer. Add this one must be smaller or equal than this one. Okay. All the constraints have been set. Let's see what happens if I press solve. It suggests 4 large and 4 small. Okay, I don't spend all the money. Okay, by the way, it's impossible. Given the prices of 17 and 32, it's impossible to spend exactly all the money. So fine. So since I arrive at 4, this function is fine. However, if you want to put something more serious for this part here, you can do it like this. Plus 100 multiplied by b2 divided by 3, okay, but only the integer part, so round down, okay. It means that if b2 is equal exactly to 3, this will be 1. If b2 is equal exactly to 4, it will be 1. If it is equal to 5, it will be 1. If it is equal to 6, it will be 2. Okay, so this the result of everything must be the same. Let's rerun the solver to check. Solve. Okay, 4, 4. Okay, and I save my sheet because you never know what can happen. Okay, let's see exercise 3.6. I change sheet, make it larger, make it larger. The electro-poly corporation is the world-leading manufacturer of slip ring, blah 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 blah. The company received a $750,000 for various quantities of 3 types of slip ring. Okay, let's see what the company really needs. Okay, so to produce a slip ring model 1, they order 3000. To produce, we need 2 hours of wiring and 1 hour of harnessing, model 2 and model 3. Unfortunately, we have a limited capability of 10,000 hours of wiring and 5,000 hours of harnessing. Okay, if it were like this, it would have been already a difficult task, but moreover, we don't have only the cost to buy, the cost to make, sorry. We have only the cost to buy one, because we can buy the things that we don't produce. Okay, so a really tough problem. Okay, let's start. So, first of all, identify the variables. The variables here are 6. So, model 1 make, model 1 buy, model 2 make, model 2 buy, model 3 make, model 3 buy. Okay, let's start putting some numbers. Just 1, 2, 3, 4, 5, 6. Okay, objective function. The objective function is to, what do you want to do? We have a cost to make and a cost to buy. Well, to minimize the cost, I would guess. However, let's try to copy this thing here. Copy. Let's see whether we can copy, for example, here. Yes. So equal. So we had to minimize the cost to make, the total cost. So number of model 1 by the cost of making model 1 plus number of model 1 by the cost of making model 1 plus model 2 make, model 2 buy, model 3 make, model 3 buy. Okay. Or if you organize this table here and this variable here in a better way, probably you can use some product or some other tools. Here I have to type it manually. Okay, this is the cost. Well, it's in euros. If you really want, you can decide that it's in dollar. Okay, save after all this effort. Constraints. Okay, the first constraint is that the sum of model 1 make and model 1 buy, the sum of model 2 make and model 2 buy, the sum of model 3 make and model 3 buy must be exactly equal to the number of things ordered. So, model 1, model 2, model 3. Okay, equal. This one plus this one equal this one plus this one equal this one plus this one. Okay, now take my base to be exactly equal to how much? 3,000, 2,900. 3,000, 2,900. Okay, save. Do we have other constraints? Ah, yes. We cannot make more than the total capability of wiring hours. Okay, let's take also this table here. Let's see whether I can copy it somehow. No, I can't copy it. Okay. Copy. Let's put it here just to remember it. Okay, so wiring. For the models that we make, we have a wiring limit. So the model that we make equal this one by plus this one by this one plus this one by. Otherwise, if I don't put these constraints here, the solver will answer immediately, well, produce everything by yourself, because as you can see here, it costs much less. So that's what the solver will answer. So I have to put the constraints that we have on the production. This must be smaller or equal, and then we will see what harness equal by harnessing cost plus this one by the harnessing cost plus this one by the harnessing cost. Okay, let's see what are the costs for harness. The maximum capability, 100 hours of wiring, 500, 10,000 and 5,000. So 10,000 and 5,000. Okay, I think we have done everything. Ah, don't forget that all these things I think must be integral. You cannot produce a half ring. So let's put here simply everything integral. No, not really everything, every variable. Okay, save. Now let's put the data into the solver. Objective is this one. We want to minimize, pay attention, by changing the variables. This one's constraints. So this one exactly equal to this one. And this one exactly equal to this one. And this one exactly equal to this one. And oops, this one smaller or equal to this one. Ah, this one smaller or equal to this one. Add this one smaller or equal to this one. Add this one integer. Add add okay, this one integer. Add this one integer. Add this one integer. No! And now you understand why you have to save, and this will happen to your exam. Somebody's working, suddenly crash. No, I don't want a blank workbook. I want my workbook. No, let's quit Excel. Okay, luckily I had saved, but before inserting data into the solver. So set objective this one, minimize, changing variables. Okay, I go as quickly as possible. This one exactly equal to this one, and this one exactly equal to this one, and this one exactly equal to this one, and this one smaller or equal to this one, to this one, add this one smaller or equal than this one. May I add? Okay, this one integer, add this one integer, add this one integer, add. Have I already done this one? I don't remember. Add this one integer, add, and finally this one integer. Okay. 3 equal, sure, okay. B2, 3, 4, 5, 6, okay. Now I click solve and I cross my fingers because if it crashes I have to insert everything again. Okay. Let's see what does it suggest. Save first. Okay. Let's see, it suggests to make alt model 1, to split the model 2 half and half, and to make alt model 3. Really? Let's see. It's because model 3 and model 1 requires very few harnessing, while model 2 is rather tight on harnessing, and harnessing is a weak point, as you can see from here. It reaches the harnessing. Moreover, well, the difference more or less the same. So it requires to make everything by himself on model 1 and model 3, and to split model 2. Let me see, we have something else here. Given the number of make it to buy, apply a 2D sensitivity analysis to evaluate the, so I have to modify, I have to evaluate the total cost varying the cost to make for model 2 from 20 euros to 60. Okay, so, oops, 2D sensitivity analysis. I need some space. So let's do this dirty trick. I hide these columns here, just hide. Wait, I cannot hide because I need them for this 2D sensitivity analysis. I modified the make of model 2 and the buy of model 2. Yes, I need them for the sensitivity analysis. Just shrink them. So I shrink here everything. Okay. Okay, let's put the sensitivity analysis, for example, here. So as we have seen last time doing class, we have to put here the function. Is it necessary to have all the digits? Can't we remove some digits? Okay. Then here all the values of one variable. So cost to make model 2 from 20 to 60, 20, 25 up to 60. Okay, and here the cost to buy of model 2 from 10 to 50, 10, 15 up to 50. Okay, now select everything. Okay, select everything. Okay, data, what if analysis, data table. Okay, row input cell, what to replace for the row. Let's see, in the row it's the cost of make, so for model 2, this one. Okay, and in the column the cost of buy for model 2. It's interesting to notice that the original costs were not included here. Okay, done. Obviously, don't find the original value because the original cost 83 and 97 are not here. It drives up to 60 and 50. Okay, obviously, since the two costs are lower, everything is lower. Let's see what else. Given the number of slip rings to make and to buy that minimize, evaluate the total cost varying the cost to make of each model. This is a scenario manager. It's a scenario manager in which you change the cost to make. You keep the original, you put the other 60, 50, 70, and the other one. This is rather easy, and I don't want to offend you trying to solve it instead of yourself. Okay, I saved this horrible thing. A little remark, please notice that in this exercise, the fact that the original order was this one is totally irrelevant. Okay, it's relevant for the company because the company can say, very well, we managed to produce everything with a cost of 453,000, so it's profitable. Okay, so it's relevant for the company, but for solving the exercise, this one is totally irrelevant as it happens in real life. Okay, we can stop here the video.